Hey guys, this is the last topic in your PDE, so let's quickly finish this. So let's say you have a function u that is a function of x and t. I'll write this as f1. So what we'll do, we'll assume this u can be written as fx times gt. Here f is only a function of x and g is only a function of t. So when you write del u by del x, we are basically only differentiating this because gt is a constant as the partial differentiation is being done with respect to x. So if you are differentiating a single variable function, that means you do not need to write del by del x. You can simply write d by dx as there is only one variable. So you can write this as d by dx of fx times gt or f dash x times gt. Similarly, when you find del u by del t, it is fx times d by dt of gt, which means fx multiplied by g dash t. So let's quickly solve this with an example. 3 del u by del x minus del u by del t is equal to 0. So I'm gonna substitute del u by del x and del u by del t with these. So this is gonna become 3 f dash x gt minus fx g dash t is equal to 0. So let's write this as 3 f dash x gt is equal to fx g dash t. Let's modify this a little so it looks the same. So let's assume this is equal to k. Now I'm gonna write this in a different way. So 3 and fx, 3 upon fx. And what is f dash x? It is d by dx of fx. Similarly, let's just start, we'll write this as k. So if I write this like this, 3 d of fx by fx, and I take the dx over there, is equal to k dx. Let's take the 3 to that side as well. And now let's integrate this. So d of fx divided by fx. You can see that this looks basically like dy upon y. So integration of this is what? ln y. So this is exactly like that. So this becomes ln fx. And this will become kx by 3 plus c1. So instead of c1, I'm going to write ln c1. This is being done so that the next step becomes easier. So we'll write it ln fx minus ln c1 is equal to kx by 3. So ln of fx divided by c1 is equal to kx by 3. So this means your fx is equal to fx by c1 is equal to e raised to kx by 3, which means fx is equal to c1 times e raised to kx by 3. So this is your first solution that you need to remember. Now let's do the similar thing for this. So we had this is GT. So let's solve this. So this becomes 1 by GT d by dt of GT is equal to K. So again, this is t GT by GT is equal to K dt. So let's integrate. We are gonna get ln GT is equal to KT plus ln C2. So ln GT minus ln C2 is equal to KT. So ln GT by C2 is equal to KT. So GT divided by C2 becomes e raised to KT. That means GT is C2 e raised to KT. So now remember, in the starting we assumed u is equal to fx into GT. This is your GT and this is your fx. So let's multiply them. C1 e raised to kx by 3 multiplied by C2 e raised to KT. So we'll multiply C1 and C2. These are both constants and the multiplication will give us a new constant. We'll call that C. E kx by 3 plus KT. So you can write u as C e, let's take K common, x by 3 plus T. This is the value of u. So this is your answer, except if in the question you are given some initial condition, then you have to find out the value of C as well. For example, in this question, we were actually given a condition. I haven't written it. So you are given that u of 0 comma t is equal to 5 e raised to minus t. This is an initial condition that is already given in the question. So what does this mean? This means that when you replace x by 0 and t with t, then you get this value. So let's try this. So u of 0 comma t is given as 5 e raised to minus t. So let's put x as 0 in this equation. C e k 0 plus t is equal to 5 e raised to minus t. So C e k t is equal to 5 e raised to minus t. So when you compare these, you get C is equal to 5 and k is equal to minus 1, which means your answer is, you're going to replace C and k in this equation again. So your final answer is u is equal to CE minus, 5e minus x by 3 plus t. This is your final answer. So this is how you use method of separation of variables. If you guys have any doubts, leave them in the comment section.